Okay, so we have to find a power series representation of this function and also find its interval of convergence. So how do we do that? Well, we try to look for something that we recognize from series that are similar. So with this one, it reminds me of the geometric series. And the sum of a geometric series looks very similar to this. What is a geometric series? Well, we had our initial term, and then we had our common ratio taken to some power. The sum of this looked like this. We had a over 1 minus r. That's how we found the sum of our geometric series. And notice that this looks very similar to this. So we can interpret our function as the sum of that geometric series, and then we can get our series in reverse by looking at this, which is very similar. So our a would be 1, right? Our a would be 1. Our 1 we can leave the same, and our negative r, we're subtracting, but here we have a positive, so we need a negative x in there. And so now we can substitute everything back. So a is going to be 1, because we got that from here. So this is the geometric series that we're getting. 1, r is this, right? So that's just negative x to the n. And we can just, to make it look nicer, since this is negative 1 to the exponent of n times x to the exponent of n, we can have this. And now it looks even more like our standard form of a geometric series. Okay, so now we need to find our interval of convergence. So we have to remember, where does a geometric series converge? The geometric series converges when the absolute value of r is less than 1. So in our case, r we found out was negative x. So that means that we plug negative x into that r and find where that is less than 1. So with the absolute value, that's the same as putting that between negative 1 and 1. And we absolute valued it, so that's x. So this is our interval of convergence. And therefore, our radius of convergence is 1. 1 is our radius of convergence, because we go 1 in a positive direction and 1 in a negative direction. So that's what our answer would be for this problem.